Welcome back. In this third tutorial, we'll build on the model from the last video by adding a second layer to create a proper 3D groundwater model in Anaqsim. Since we're starting with the model from the previous tutorial, this video will be a quick one. Up to this point, we've created 2D models using a single layer. While you can adjust the thickness of that layer to match your aquifer, those models can't capture true 3D flow effects. By adding layers, you'll be able to simulate more complex groundwater systems, like aquifers separated by aquitards or multi-layered flow systems that are common in real-world projects. Let's take a look at the conceptual model for this example. We'll use the existing hseg domain from the previous model, modify the layer thickness, and add a new layer below. The total thickness of this updated model will be the same as the one we built in tutorial 2. We're just redistributing it between two layers. But as you'll see, by creating this lower layer, we can effectively limit the thickness of the low permeability subdomain and thus change the flow characteristics of the entire model. The first thing we need to do is modify the thickness of the existing domains. As you'll recall, we had two domains, one named aquifer and the other channel. If you chose different names, that's fine. Just remember that one domain represents the main aquifer and the other represents the low permeability infilled channel we simulated. To modify these domains, first go to Model Input in the top menu bar. Then select Domains from the drop-down menu. Now modify the input table. For both the aquifer and channel domains, change the bottom elevation to 40, keep the top elevation at 50, and leave the average head at 47. These adjustments reduce the thickness of the existing domains to make space for the new lower layer we'll add next. And just as a reminder, this model was created using the units of meters and days, so the elevation values are in meters. Next, we'll create a new domain for the lower portion of the aquifer. Left-click on an empty line or press Enter to create a new line. In Label Unique, enter a unique name such as Lower Aquifer. Then set level to 2. Choose Confined Unconfined as the domain type. Next, set top elevation to 40 and bottom elevation to 35. Notice that the top elevation of this layer is the same as the bottom elevation of the layer above. Then set average head to 47 meters. Use the same input parameters as the main aquifer for porosity, storativity, and hydraulic conductivity. Now save your new layer input by clicking File and then Save. One of the great things about Anaqsim is how easy it is to modify your model. Because there's no mesh, adding layers or changing parameters is quick and flexible, perfect for testing different scenarios or refining your model as new data comes in. Now that we've created a new domain, we need to define its boundaries so Anaqsim knows where to place it. For this example, we want to stack the domains within the same footprint as the layer above. The easiest way to do this is by using the hseg boundary generator again. Here's how. First, go to Model Input and select Line Boundaries. From the drop-down menu, choose Head Specified External with Gradient. Then, in the Domain field, select Lower Aquifer. Now, enter the same values as the main aquifer boundary. For center XY, enter 0, 0. For radius, enter 2000. For gradient, 0.0001. For gradient direction, 135 degrees, pointing northwest. Then set parameters per line to 3. This provides a good balance between resolution and calculation time for this model. When you're done, save your input, go to File, and click Save. And that's it! You've successfully turned your one-layer 2D model into a two-layer 3D model in Anaqsim. Now let's run the model again to see the results. Click Solve in the top menu bar. Next, go to Make Plot in the top menu bar and select all selected features, choose Level Time. Notice that you can choose either Layer 1 or Layer 2. Start by selecting Layer 1, and you will see the hseg boundary and your ellipse that represents your infilled silt channel. Now notice how the groundwater flow bends around the silt channel. Now go back to Make Plot in the top menu bar, and again select all selected features, choose Level Time. This time, select Layer 2. Notice now that your silt channel is not there because it no longer penetrates the full thickness of the model. It's now limited to the upper layer. Since the main aquifer and lower aquifer domains have the same properties, they behave like a single continuous unit. This setup means the infilled silt channel has been made vertically discrete, allowing you to better simulate stratified features within an aquifer system. Before we go any further, it is important that I note that back in Tutorial 2, we chose an ellipse as the shape for our infilled silt channel, simply for convenience. In practice, you can use any polygon that you need to define your subdomains. Now, while we have given this model a third dimension, there is just one more step required to simulate 3D flow, and we'll cover that in the next video.